Okay, Nana. Now see. First, let me discuss about the drawbacks of Bohr's theory. Now, drawbacks of Bohr's theory. So, in drawbacks of Bohr's theory, first one, it is applicable for hydrogen and hydrogen like atoms only. Okay, it doesn't explain the. It is not applicable for. It is not applicable for
డాట్ ఎక్కడ కనిపించింది
multi-electron system. Doesn't applicable for multi-electron system. And next one. It doesn't explain spectrum of multi-electron systems. I will tell you what is spectrum.
రేపు మేడం దగ్గర రాసుకో
And it doesn't explain why angular momentum is quantized. Why angular momentum is quantized, and this theory doesn't explain Gmon means splitting of spectral lengths in a magnetic field. And Stark effect. Stark effect means splitting of spectral lengths in electric field. Okay, it was not explained splitting of splitting of spectral lines in electric field and magnetic field. Okay.
Sir, could you go to the previous slide? Yes, sir.
Hello. Now, can you hear me, Nana?
Yes, sir.
Okay. This is about the
Sir,
tell me, Nana.
sir, what is the real reason why angular momentum is always quantized?
He was not explained, no. That we will discuss in Bohre, de Broglie's theory.
Okay, sir. Sir, and one more thing, could you explain the last point?
Splitting of spectral lines and magnetic, like
Yes, sir.
electric and magnetic field, no.
Zeeman and Stark effect.
I will explain first. We should explain about the Stark effect, right?
Okay, sir.
Mm.
Sir, means the spectral lines they get irregular, sir. They get
Yes,
divided.
yes.
Sir, 1 minute, sir. Sir, but spectral lines are always parallel and proper, no, sir.
Not like that. Spectral lines means simply if you are talking, no. Spectral lines mean how we will get spectral lines like this. Okay, na? So
Yes.
whereas this line is there, no, this is one spectrum, right? One peak, right? So if that one peak having again some other peaks like this,
Okay, sir.
this is known as splitting of spectral lines. We can say,
Okay. Sir,
okay,
means
that
the
that will takes place in electric field as well as magnetic field also. Okay,
all
so what
spectrums
is the
have, sir.
reason for that splitting in electric field and magnetic field? That was not explained.
Okay, sir. All spectrums have like this, sir.
Yes. Okay. Next one. First, we need to discuss
Sir,
about
once
the.
can you put previous slide? Sir,
Uh,
sir, you wrote
Is angular momentum.
multi-electron system.
yes.
Sir, what does it mean?
Multi electrons means which is having more than one electrons.
Sir, that means helium also come into
Uh,
multi-electron system.
yes, yes. Okay.
Sir, sir, multi-electron system में just more electrons atoms, sir.
More than one electron, simple.
Atoms only, sir.
Yes.
Okay, sir. Sir, and you wrote splitting of spectral lines in magnetic field, no, sir.
Uh,
That means if we apply magnetic field, they will split, sir.
yes. That
Okay,
meaning
sir.
that only, no, if what we have written. Okay. Now,
Completed.
see. So, first we need to know about the what is simple. I will define about what is spectrum and what is uh, hadron spectrum we are going to discuss. Take a simple. Let me write spectrum and what is meant by spectrum and hadron spectrum. Spectrum and hydrogen spectrum. Okay. Now say spectrum is, for example, let me take this is a prism, right? When a light from here is there, this light can be from the emitted or absorbed light. Okay. So this light, when it is falls on this, when this white light is okay, white light is falls on the prism, and if you are trying to observe the nature of the prism or nature of the light in photographic plate, this yes, photographic plate, black plate it is, okay, na?
Dispersion.
So then light will split into different colors. That only we are saying, no, violet, indigo, blue, green, yellow, orange, and red. Waves here, okay. In this one, which is having
Red.
highest wavelength?
Red, sir.
Mm. So highest wavelength will be for red. and least frequency will be red only. Okay, na? This entire setup, what we are saying that no, this entire process we are saying that spectrum we can say. Okay, this entire setup or entire process we are saying that simply we can say it is a spectrum.
Sir,
Tell me, Nana.
sir, violet light will have more deviation, right?
Yes.
Sir, but you wrote violet light at top.
Acha. Actually, it will should come from bottom
Yes.
to top. Actually, I have written
Yes, sir.
in reverse direction. I have
Wavelength
written,
and
right?
uh, frequency are the correct, but they should be opposite.
No, frequency and wavelength are
Yes,
opposite
sir. V
only,
will be
but the
double.
deviation when we are observing, no, so violet color will have more deviation. Actually, from the bottom, it's supposed to be. Okay, increased wavelength will be like this. Okay. So this spectrum we are saying that. That means simply what we can say. So when light falls onto the prism, so light is going to get dispersed into different colors or different wavelengths. That only we are saying that simply spectrum. Okay, if we are using some emission light, we are using the light from emitted, then we can say it is emission spectrum. Okay, the spectrum again generally we are having two types. Okay, spectrum is emission spectrum and absorption spectrum. Okay, now we are going to discuss about the emission spectrum only we are going to discuss. When the emitted light fall onto the prism, no, it will split into different colors. Okay, that we are going to actually uh, the spectrum of
Sir, once go to previous slide.
atom, 1 second, are molecules, atom or molecules are observed in spectrophotograph. Spectrophotograph. And this study related is study related to spectrum are called as a spectroscopy. Spectrum is called a spectroscopy. Okay, spectroscopy is branch of a study which studies about the spectrum of different atoms.
Sir,
Sir,
Tell me.
sir, that means the whole process is called spectrum, or the lines are called spectrum.
This is called spectral lines. Okay, the individual lines are called spectral lines. Okay.
Sir, what
That
is
means
that
process
photographic?
is called spectrum, sir. Then
Huh?
the process, sir, the process.
The entire what we are getting, the dispersed light which we are getting on the photographic plate or not, that we are saying that spectrum.
sir,
Okay.
Yes. Okay, sir.
And here, once we have asked a question, no, let me finish, no. Okay, and the spectrum absorption spectrum in which we are going to have one instrument which is known as spectrophotometer or spectrophotograph we can say. For example, if you observe ECG, we will observe some lines on one paper we are going to get, no.
Yes, sir.
So that machine we are saying that spectrophotograph or spectrophotometer we are going to say simply. Okay,
Okay, sir.
and the study related, for example, how individual atom behavior spectrum will be there, how it will be there. If I'm taking a particular matter molecule, if I'm taking how its behavior will be there, so that we are going to study under spectroscopy, a study related to spectrum of atoms and molecules.
Okay, sir.
Mm.
Sir,
Mm.
sir, spectrum of an atom or molecule means the atom or molecule is acting like the prism, sir.
How atom or molecule will acting as prism?
Sir,
So
then yes, sir.
so when, if you are observing a hydrogen gas, how its behavior it will be there. If you are taking water molecule, if I'm taking,
Yes,
okay,
sir.
so how its behavior is there, that we are saying that how, if you are taking an atom, how that dispersed light will converts, how the light is changes. If you are taking molecules, no, or if you are taking compounds, how its behavior will be there.
So on that atom or molecule, how white light behaves.
Yes.
Sir,
Okay.
the spectral lines also indicate the or shells, sir.
No,
Okay.
from spectral lines wavelength, by knowing the wavelength of the spectral line, no, we can predict from which cell it is emitting, that we can predict.
Okay, sir. Only from which shell?
Okay, or from which cell it is jumping, electron is jumping,
Okay,
that we
sir.
can observe.
Sir, Lyman series, those all are these all enough, sir.
Next one, see. Yes. Now see. So when hydrogen gas is observed, hydrogen gas is uh, observed in spectrophotometer. Okay. Mm. So it contains, what we can say, hydrogen gas, when we are observing the behavior of hydrogen in spectrophotometer, no, it observed that, okay, it contains different different series of spectral lines. Okay, and each series spectral lines will also be is named in the name of, named after the scientist. Spectral lines are named in the name of scientist అనమాట. Okay. Mm. So what we are going to get see here now in this one, for example, uh, so as I told you, there are different number of cells will be there, no, different as per hydrogen, and as per Bohr's theory, we are having different infinite number of spectral lines are there. Yes or no?
Sir, infinite number of shells, no, sir.
That one I'm telling you, no, infinite number of cells are there, no. So that infinite number of cells, how we are going to get see here. For example, that each cell I'm taking as a one line. Okay, let me take like this. This is one spectral line. Okay, na? Or each one line, and this is second line. Let me take like this. Second line indicates a second shell. Okay, na? This is fourth line. Let me take a fifth line, sixth line, or seventh line. Up to how much we can have? Infinite levels are there. Okay, na? Up to infinite levels are there. Let me take, this is first line, second cell, third, fourth, fifth, sixth, seventh up to infinity. Okay. When an electron, okay, for example, let me take if in a hydrogen atom only, having only one electron, right? If that electron is excited to infinite level, let me take, okay, by absorbing some amount of, by giving some amount of energy to it, so it will excite to infinite level. Okay, the higher level always I'm going to indicate with n1, sorry, n2, and lower level I'm going to indicate always with n1. So what I'm taking, so let me write here this series, and lower level I'm writing n1, higher level I'm taking n2, and I'm going to identify the region also. We can identify by knowing the formula. Okay. Now see here, if an electron, it is excited to infinite level, so it can come from infinite level to first level also, or it can come to seventh level to infinite level, sorry, 7 to first level also. From which cell it is coming, it depends on the how much of energy you are supplying to it. Are you getting what I'm trying to say? So depends on the energy. Okay, depends on the energy, the electron can excite to second level, and as we know, the electron is more stable, or its original position is first cell only, so it will come down to its original position again. Okay, by emitting some amount of energy, that energy we are saying that this 2 to 1, this is saying that transition, and this line or corresponding wavelength or wave number, we are saying that spectral line, we can say. Understood, students, what I am trying to say?
Sir,
Sir, here we are providing the energy.
Yes, we are in the sense, then spectrophotometer, no,
Yes, sir.
that energy we are going to use, no, that energy is providing. Okay, na?
sir,
Okay, sir.
exciting means
Now see, here,
sir, exciting means jumping from lower level to higher level, sir.
uh, higher level to lower level,
Oh, okay,
nana.
sir.
Then only emission of energy will
Yes,
take
sir.
place, no. Okay. Now see, these all spectral lines are belongs to coming down to which series it is? First
Light
line,
one.
no. Uh, Please quiet if you know. Mm. Now see, in the same way, it can come from infinite level to second level also, no, or from next level to second level.
Bomber, sir.
Array, I said quiet if you know. Already we have discussed this. Okay. So this type of series also one possibility is there, no? This is one series. And similarly, what? Even from infinite level to, it can reach to third level also. Okay. So these are all called as spectral lines, we can say. Series of spectral lines, we can say. This is named one series. And after that, what? It can come down to fourth level also. Okay, it is named one series, and even it can come down to fifth level also from infinite. Okay, so this series only they have named differently. Actually, the first series was identified by Balmer, that is second series,
Visible source.
and the first series, that means by taking ground state, we are saying that Lyman series, and this is called Parsons series
Bracket.
and bracket, and this is fund series. Okay, now coming into this is standard actually for Lyman series. The ground level will be always 1, and second level will be from 2, 3, 4 up to infinite we can have. Okay, and this we are going to observe in ultraviolet region. And next one is Balmer series. In Balmer series, n1 value is 2. This is fixed actually, and higher level will be
Sir, what are N1 and N2?
h- earlier before writing only I told you
N
no. N1 is ground level. I'm indicating lower level I'm taking as N1 and higher level I'm taking as N2. I
first
told
one,
you
sir.
no.
N2 means before exile.
Ah,
Okay,
yes.
sir.
Lyman Balmer and next one Pasha.
Infrared.
So 3 and it is going to from 4, 5, 6 up to infinite. This will be IR region. Next bracket.
This also infrared.
This will also IR only. Next one fund series.
5 infrared.
This is also IR only. Okay. Now see N1 means for example in case of Lyman series. So this is N1. 2, 3, 4 will be higher levels. No, that will be N2 levels. Okay, na?
Yes.
Mm. So as we are saying, this is spectral line, right? Which I'm so that spectral line wavelength or wave number also can be calculated. Okay,
Sir, once can you go to page?
one second. Anna. The spectral line, wave number and wavelength can be calculated by using Rydberg's equation.
Sir, what is wave number?
That is,
Sir, not
what is
wavelength, sir.
wavelength?
Wave number.
Who is asking? May I know that person? Wave number and wavelength you don't know, Rohan.
Sir, I know wavelength, sir. Wave number, I don't know.
At very first classes we have discussed, right?
The
Sir, once can
reciprocal.
you go to the third
So
slide?
1 by n1 square minus 1 by n2 square into z square.
Wave number means reciprocal of wavelength. That only, no,
Ah,
sir.
No,
Okay,
sir.
sir. I think I just
Third,
forgot, sir.
N1 and 2. Third slide, sir.
okay.
Sir, can you show the previous slide?
Completed, sir. Thank you, sir.
Sir, can you show the previous slide?
Sorry, Nana, okay. Some call. See, so this is about the so that wave number and wavelength can be calculated by using this Rydberg's equation, right? This is the way we can calculate this. And one more point, he said that. Now see, so he has given this is the first line. Okay, this is the first line. Let me write like this with red color I'm indicating. In any series, this is the first line, and this is going to become limiting line. Even in Balmer series also, what is the first line, Nana? 3 to 2, right?
3 to 2, sir.
And infinite line will be, limiting
Infinity.
line will be
Limiting.
infinite to 2. Okay.
Yes.
Now I'm going to compare. If you take any series, what can be the wavelength of limiting line and what can be the wavelength of first line? I'm going to calculate now. What is that I'm going to calculate now? First one, what? For limiting line of any series in hydrogen spectrum, for hydrogen spectrum, n2 is infinity. Okay, n2 is infinity. Now for example, you can take any series, right? But I'm taking first example, I'm taking of Lyman series. I'm taking, let me take a Lyman series. In Lyman series, for first line, what is n1 value?
1,
And n2 value will be
2.
2.
Infinity, no, sir.
now. Therefore, nu bar equal to 1 by lambda equal to calculate r. Here I forgot to write RH value. RH is known as Rydberg's constant, and that value is 109,677. Okay, centimeter. RH into 1 by 1 minus 1 by 2 square, right? And this value will be how much? 1 by lambda equal to RH into 3 by 4. Now if I'm calculating lambda value, lambda equal to what? 4 by 3 into 1 by r, right? Keep this one, don't solve because we are trying to compare, no?
Sir, 1 by Rydberg's constant, sir.
Yes.
Yes, sir.
Sir, 1 minute, sir.
1 second, 1 second.
Done.
Now see, for limiting line, n2 will be how much? Infinity, and n1 value will be 1.
1.
Therefore, what we can say, nu bar equal to 1 by lambda equal to r into 1 by 1 minus 1 by infinite. That will be how much? It will be 1 by lambda equal to r, and therefore lambda equal to 1 by r, isn't it? R or RH, you can take no issue in that. Okay.
Sir, 1 by infinite is how much, sir?
Uh,
1 by infinite.
1 by infinity is 0, no?
Oh, okay, sir. Yes.
Okay.
Yes.
Next. Next point is, see. Next point is, now if I'm comparing first line and limiting line, which is having highest wavelength?
Sir, what is RH value?
RH value already I have written, see here. 109,677.
Sir, how lambda is equal to 4 by b into 1 by r?
B nahi, it's 3. 4 by 3.
Sir, what is 1 by r?
And 1 by R is R value is constant. No, I said. Just I'm comparing first line and limiting line, which is having highest wavelength, that I'm trying to compare.
Sir, how 1 by r came, sir?
And 1 by lambda equal to RH into no.
Reciprocal, sir.
Reciprocal I did no, lambda equal to. That will
Okay.
be 4 by 3 into 1 by R, it will become, right? Mm.
Thank you,
Uh,
sir.
n- Now tell me, which value will be more? Limiting line value will be more, or line first line will be more? Which
Sir,
value will be more?
next slide.
Sir, Bohre, sir.
Yeah.
Arey yaar, I have taken
First
example of
line.
Lyman series,
Sir,
no?
first line, sir. First line, sir.
First line wavelength will be more or not?
Yes, sir.
Yes,
More.
sir.
Because both have
Mm.
one by RH.
Okay. That all I am telling that in any series, first line will have, first line is nothing but a short line also we can say. Shortest line, no? First line, which is also called as shortest line. In any series, first line or shortest line will have highest wavelength, right? Highest wavelength, and whereas limiting line which is also called as the longest line will have shortest wavelength. Can we say? Okay, no? Mm. Is this play point clear? Students, is this point clear, Nana?
Yes, sir.
Now see, next point is next series is now see here. This is the first line, right? In any series. Okay. That first line in any series we are going to represent with H alpha, and this second line will be represented with H beta. Third line will be alpha
H
beta
gamma.
gamma, and fourth line is H delta. Even in Balmer series, what can be the first line? For example, let me take
Beta, sir.
for example, in Balmer series, hmm, H alpha for H alpha, right? What is N1 and N2 value? Tell me. What is N1 and N2, Nana?
N1 is sir. N1 is 1 and N2 is infinity.
Balmer.
N1 3, is sir. 3. N1 is 2.
N2 is 3 and
N1
N1
is
equal
2.
to 2. Very good. and H beta line in same Balmer series only. N2 will be 4 and N1 will be 2 only. And H,
Sir, I didn't understand the H beta line, sir. What is
Sir,
that?
you did not tell now again, sir. Alpha, beta, gamma.
one second,
Sir, I didn't understand.
1 second. Okay. So, what did I say? This is first line, right? This only first line we have defined in Balmer series. Are you looking at the board or not? This first line only, it was represented as a H alpha. Alpha line, it was said. And this is second line, right? That is given as H beta. And third line is given as H gamma. Fourth line given as H delta. Okay, that Balmer only he said like that: H alpha line, H beta line, H gamma line, and H delta line. Okay.
Sir, I have a doubt.
Ask me, Rohan.
Sir, these alpha, beta, gamma, delta, are they the only four, or after delta can we continue like
Can we continue? But only Balmer he had
yeah.
given like that H alpha, beta, gamma like that.
Okay, sir. These four are the
Okay,
main,
that's
but
for
we can continue.
we can continue, but only H alpha, beta like that only that no. So if they are asking what is the wave number for H alpha line, at that time you should know, no. That's the reason I'm giving this.
Okay, sir.
Okay. Time అయిపోయిందా?
Yes.
This is H alpha, H beta lines. Okay. Understood?
Yes, sir.
There are two more points are there. Okay. Just wait for 2 more minutes. We can close. Okay. Now the question is, see, how to calculate number of spectral lines.
Sir, once can you go to previous slide?
1 second. I will give you this. Okay. General, I will give you the formulas for number of spectral lines, and that explanation I will do tomorrow. Okay. Number of spectral lines. There are two formulas that is n into n minus 1 by 2. Okay, first formula. When lower level is not known. Level is not known. Only higher level known. If both lower level, that is n1, and higher level are known. Are not. Then number of spectral lines is equal to summation of n2 minus n1. Okay, summation of n2 minus n1. Okay. By taking examples, tomorrow I will explain these formulas. Okay.
Bye,
Bye,
sir.
students. Good night.
Bye, sir. Thank you, sir. Good night, sir.
Thank you, sir. Bye, sir. Good night, sir.